Okay, here's another example, and we are asked to find the transfer function of VL over Vs. So that's the transfer function, the ratio of the voltage drop across the 2 Henry inductor on the output where we have our VL down there, and the input voltage. I could have said probably VL2 because we have two inductors there, because note, you're gonna have a VL here as well. So let's say VL2, VL1 here, so that we have let me just say VL2 just to avoid the confusion. So the first thing that we want to do is we want to write our equation in terms of our mesh analysis. Then we can continue from there. Let's say write mesh equation for loop 1. Here we have, let me write it this way. We have 2 Henry across the first inductor in L1, di dt, plus we have voltage drop across the 2 ohms resistor, and subtracting our current, you have I1 minus I2. It's equal to our supply voltage. From there we can write our Laplace transform. So now I'm going to go a little bit faster because these equations tend to take a bit longer. So to take the Laplace transform of that, we have 2s. This is supposed to be I1, so we're gonna have I1 of s plus 2 I1 of s minus 2 I2 of s is equal to V of s. Okay, and we can write, I can pull the I1 of s on one side, so here we can have 2s plus 2 times I1 of s minus 2 I2 of s is equal to V of s. Okay, so we are going to use that equation. Next we can write the mesh equation for loop 2, and for loop 2 we have 2 I2 minus I1 plus 2 I2 plus 2 di2 dt is equal to 0, and I'm just going to expand this bracket, 2 di2 dt plus, then I can expand that bracket to have 2 I2 minus 2 I1 plus 2 I2. Okay, it's equal to 0, and apply the Laplace transform. We have 2s I2 of s plus, here we have 2 I2 of s minus 2 I1 of s plus 2 I2 of s is equal to 0, and from there I can pull the I2 out. So we are going to have this equation 2s I2 we have plus 2 here, plus you have another 2 there, times I2 of s minus 2 I1 of s is equal to 0. So just clean this one up to have 2s plus 4 I2 of s minus 2 I1 of s is equal to 0. So we have our two equation, and we are going to, let me just write down the equations properly so that we are going to take the Kramer's rule. So the first equation we had, I'll write it in green. Let me use this color. Our first equation we had 2s plus 2 times I1 of s minus 2 I2 of s is equal to our supply voltage. And our equation that we just found here, we have minus 2 I1 of s plus 2s plus 4 I2 of s is equal to 0. And from there we can write this into a matrix format whereby we want AX is equal to B, and we can find our X is equal to A inverse times B, or apply the Kramer's formula. So I'm going to use the Kramer's formula here. And if you are not familiar with the Kramer's formula, please look at our previous example. So say we are going to have an A matrix times something is equal to something, okay? And we can see here we want A1 of S, A2 of S, because that's what is common to both of them, and it's equal to V of S and 0. So here we are going to have 2S plus 2, and on the diagonal we have minus 2 and minus 2, then 2s plus 4. So now from Kramer's rule we want to solve for I2 of s, okay? And applying Kramer's rule, we have I2 of s is equal to, so we take the determinant of the top part. The determinant, we're gonna have 2s, and we'll replace the minus 2 with vs. Then we have our minus 2, replace the 2s plus 4 with 0 over the determinant of 2s plus 2, okay? And we have minus 2 here, minus 2, 2s plus 4. Then we take the determinant of that. If we do that, 2s plus 2 times 0, that's 0. So we are going to have minus 2 times vs, so it's going to be plus. So we're going to have on top 2 vs over, you're going to have 2s plus 2 times 2s plus 4 minus 2 times minus 2, okay? I'm going to rewrite it here. So I2 of s is equal to, you have 2 times vs over, if you expand that, you're going to have 4s squared plus 12s plus 4, okay? Now our equation, originally we were asked to find, what did we need to find? Okay, we wanted to find VL, you know, the VL over VS, VL over VS, and we can see that we don't have a VL here. Okay, we don't have our VL here. We need to use few tricks. We know that the voltage drop, the voltage drop here, remember you have I2 current, I2 coming here, and also I2 going through the 2 Henry inductor. So we can say that your I2 of S is equal to VL of S over 2S. Okay, and how did we get that? We know that your VL of S is equal to L I2 of S. Okay, and we know that L is equal to 2, so you can say that this is VLS is equal to 2 I2 of S, and divide that 2 by this will give you this. Okay, so I just substituted the values that we have. Okay, so knowing now that I2 of S is equal to VL of S over 2S, we are going to use this information to write it in terms of that. Then at least we are introducing a VL into our equation because we want the VL over VS. Alright, so if I do that, I'm going to say, just rewriting this, VLS over 2S is equal to the main equation, 2VS over 4S squared plus 12S plus 4. And I can cross multiply that with that. I'm just doing that to clean up the equation so that we see what we are going to have. And we are going to have 4S squared plus 12S plus 4 times VLS is equal to 4S VFS. Okay, now it's easier to find the ratio. Okay, from here we can say that VL of S over VS is equal to 4S over 4S squared plus 12S plus 4. And I will leave it in this format. If you leave it in this form, it's still fine. However, you can continue, you can get rid of this 4. Alright, if you divide by 4, then you're gonna have the denominator is S squared plus 12 and 4 is 3S plus 1 over S. Okay, or if you leave it in this format, this is also okay. Okay,